Hello and welcome back to Lambretta-Lutz. Today, again, a new part of theoretical design, as I'm currently not in my workshop, but it goes interesting today because we will see some new design cooling heads, as well as some simulation pictures and a conclusion of what will be the winner of the simulation. But let me start it actually with a goal of what is it about. So, you know that I built a Chimera with a quite high performance in the end of over more 70 horsepower. So it works very well, and even with the air cooling, but to have also a more comfortable feeling and as the time of building my own full liquid cooled twin, I want to consider how it could be a easily adapted solution for having at least liquid cooled heads for this twin kit. Again, the Chimera itself, so when you're just making it in an easily double barrel solution, works very well with air cooling, but with this performance that I have, I want to go on a more safety way. So saying that, I was actually saying, okay, then just go to the market and getting two normal heads that you can get from different dealers. But the problem is all these heads have the diameters of the barrels themselves. But the barrels are cut in the middle, shorter, so that they put suiting side by side, so there was no chance to have this on the market solutions. So therefore I make my own solution, and you see here the draft and design, and I put it simply on the top of the lid from the two-part design, the inlet and the outlet, so I'll call inlet, hot outlet. And well, I show it to friends, and then there were coming some concerns about what is about the flow, what is about the hotspots, and so on and so forth. So for me, it was in the end really a kind of time to say I need to have some terminal simulations and CFD simulations. So saying that is easy, doing it is much more complicated, but in the end the results are quite remarkable. To wrap up, what was it about is actually, so the goal was to have in this project, or I mean it's the beginning of the project, to build a liquid cooled Chimera, to see if it is a simple manufacturer design possible with the most effective heating removal from the barrels. So the design, actually, I ended up to test 4 designs. So Model B is actually the classic top layout that I just showed you. Very easy to build, but in the end it was not so effective. So I put Model A with an angled inlet, expecting that will be very dynamical in the cooling. But saying that, the results even let me then consider to have a Model C that still is very good balance of 2 designs. One is the inlet on the top, and on the bottom is the outlet. So that gives a good balance. And then by D, it was a quite surprising result by having actually it was more technical reason for the diameter of the connections to put a smaller outlet, and it even shows that the flow have been improved. So for the simulation setups, as I said, I used open tools like OpenFOAM. I use ParaView for the post-processing. I was looking for all the details for water coolant with a mixer of Liquid, and also what are the typical inlet velocities, temperatures, and volts temperature, also with the heating transfer models, and also with turbulence models to make it visible. There are a lot of parameters, and I can sure post them, but it was I think it would be too much to post it now. So for the result, the best cooling was actually the one that has angled inlet and then a down outlet, but with the idea of creating it in a more easy design, C and D have been very performant good. So not to talking too much theoretical, so you can see also some results and pictures. So I will start it with the classical design, and here you can see, so it's a cold inlet, it is an outlet, it's a heating of the down area from the head. You may wondering why this is cutting out, because it is just the water area. So sure, here is a heat transfer as well. and I could make cuttings of the lines that looks quite nice, of velocity, also temperature, but this is quite equal as you can see, and also the pressure that gives indications of hotspots. The other hotspot simulation is actually here with freehold, and this is something where you can really see with arrows how it looks the water is flowing. So the water is coming from the top, so it's cut it in half. So there's some pressure, it goes left and right around, and then it goes outside, and the pressure and the temperature is shown here. So the temperature is quite equal everywhere, but the pressure is different, with a high pressure going out of the exhaust. So, and this I did for all the different designs. So here you can see the version with angle inlet. So actually I make different kind of position to have it, to see then how's the flow going, how is the coolant going, and having here the simulation of how is it working around, and even with making a spiral. But here the problem actually, it's a little bit to see here. If you are not carefully, you could have here a shortcut. So if this inlet gets too close, the pressure and the situation in the coolant can become unstable. Still is actually from cooling wise one of the modern solution, and so that brings me from this classical design towards to having it in a mixed solution like this. So here I have a classical inlet from the top, but putting the outlet down. So, and that gives a very good flow of the water. It starts, it's spreading out, it goes to both sides equal, and then going very nice out at the bottom. And the surprising fact was, when I making this diameter smaller from 16 to even just 13, the results have been better from the temperature and from this area of having it under control, where the hotspots are. For you, maybe all the pictures look the same, but the variances are here in the parameters, and well, it took me over a week of interpretation and doing it, so to make it not complicated. So to make it more visible how actually the designs are very different. What I did not show is that here an angled inlet from the head. I will just show the easy design of having a top inlet and then the difference of how the hot water is going out. So that was a classical design that I started with, and the more other design would then be this, so that the hot water goes out here, and here I can even now make a change. I just make a reduction screw into it, so I can work with both designs, with more flow and with less flow, and bring the heat water downwards out. So I have to make 3D prints now to see if everything is fitting, also if the down pipes are not in the way, maybe with the exhaust, that I couldn't do it. For me today it was more important to show you the differences of this water-cooled design, and that I just not making some metal round and then give it a try. So there are now considered some simulations. So what would be now the winner? I mean, here I put overview of the concept of the comprehension of all four models, and you see in the table the Model C is the winner. So you're now probably wondering, why is Model C the winner if Model D is actually now better in the performance? Well, I will see it from the engineering perspective, and I see it from the performance optimized perspective. So the Model C has actually a balanced design, because it's still a great terminal performance. It's simple and proven layout. You have the same kind of connections and diameters, and so everything is very easy to produce. There are no hotspots, and so it's a simple and proven layout. So and you have still the possibility from there to reduce the diameters of outlet and then making optimizations. So with EV just installing reduction diameter threads. So from the performance optimizing, it's clear Model D the lead. So it has a slightly better cooling of the flow. The outlet with a smaller size actually is doing a stronger extraction, and it's still easy to make. So overall, so I will go in the direction Model C, Model D, and then I will let you know. So soon or later, my Chimera from the head will look in this, and now it's time to order the, making first the 3D prints, and from the 3D prints making dry build possibilities, and even there I can making visible lids to have a control of the flow in a real time. Well, just the flow, not with the heating probably, you cannot run the engine, but you can check up the flow. And well, I hope you liked it, and please comment, please subscribe, and leave a like. So Chimera is going into a liquid cool head solution. Thank you for watching.